Okay, let's take a look at some balancing equations. I'm going to follow the worksheet that I passed out in class, the one with 21 questions on it. I'm not going to do all of them, but I'll do a select few. Number 1. So the trick here, remember, we're trying to get the same number of atoms on the left side as the same number of atoms on the right side. So when I say side, I'm talking about the yield sign, also known as the arrow, is what divides the equation into the left side and the right side. So it's not just, you don't have to just look at these spacer things to figure out the left side and the right side. You have to look at the arrow. The arrow is the most important thing. The arrow is what tells you what's on the left and what's on the right. And you have to have the same number of stuff on each side. So, for example, you have to have the same amount of nitrogen on the left as nitrogen on the right. And you have to have the same number of hydrogen on the left as hydrogen on the right. Why is that? Because of the law of conservation of matter. It says that in any chemical reaction, the matter is conserved, so you can't lose or gain anything. So all we're doing is we're adding coefficients. A coefficient is a number that goes on the line, so like a number that would go here, or a number that would go here, or a number that would go here. We're just putting numbers on a line so that we have the same number of atoms of each element on the right side and the left side. So let's start with nitrogen. There's 2 nitrogens right here, and there's 1 nitrogen right here. So that's a problem, because they have to be equal. So the way that we can make them equal is we can put a number 2 right here. Now we have 2 nitrogens on the left and 2 nitrogens on the right. Next up, we're going to look at hydrogen. We have 2 hydrogens right here, and we have 6 hydrogens right here. You have to multiply the coefficient by the subscript. 2 times 3 equals 6. So we have 6 total nitrogens on the right side, and again we have 2 total nitrogens on the left side. That's not okay. We have to balance it out. It has to be exactly the same. So how can we make them both the same? Well, what we can do is we can put a 3 in this box. Oops, I erased my 2. We can put a 3 over there. So now we have 3 times 2 equals 6. 2 times 3 equals 6. So we have 6 hydrogens on each side, and we have 2 nitrogens on each side. So now we're finished. And then for the ones that you don't put anything, it's really just a 1. So we can put a 1 in there like that. This one. Where is our dividing line? It's right here. It's the yield sign, or the arrow sign, that designates the left side from the right side. And you have to have the same amount of stuff on each side. For example, let's look at potassium. We have 1 potassium right here. We have 1 potassium right here. So that's okay. We have 1 and 1. That's good. We have 1 Cl right here. We have 1 Cl right here. Okay, so that's good. 1 and 1. We have 3 oxygens right here. We have 2 oxygens right here. Uh-oh, that's not good. We got to make it exactly the same. So what's a number that we could put in one of the spaces to make them exactly the same? Well, we have 3 over here, and we have 2 over here. There's no number that we could write in here that would make this side equal to 3. There's nothing that you can do times 2 to get to 3. So when you run into this situation, you have to think of a number that 3 and 2 both go into. The number that 3 and 2 both go into is 6. That's also called the common denominator. So we need to make both sides have 6 oxygens. So on the left side we can put a 2. 2 times 3 equals 6. On the right side we can put a 3. 3 times 2 equals 6. So again, 2 times 3 equals 6. 3 times 2 equals 6. So I have 6 oxygens on both sides. So now my oxygens are balanced. Now you got to go back and look at the other things and make sure they're still balanced. So now over here I have 2 Ks because I put a 2 in front of it. So I got to go back over here and put a 2 there so that I have 2 Ks on both sides. And now I have 2 Cls because remember the number in front applies to everything. And over here I also have 2 Cls. So my Ks are balanced, my Cls are balanced, my Os are balanced. So now I'm finished balancing this equation. Here's our dividing line. We have to have the same number of stuff on the left side as on the right side. I have 2 F's right here. I only have 1 F right here. So I'm going to put a 2 there. I have 2 Cls over there. I only have 1 Cl over there. So I'm going to put a 2 there. to make them equal. Everything else looks good to me, so I'm just going to put a 1 in the blank space to finish it off. Here's our dividing line. We have to have the same amount of stuff on the left as on the right. We have 2 hydrogens on the left, we have 2 hydrogen atoms on the right. That's okay. We have 2 oxygen atoms on the left, we only have 1 oxygen atom on the right. So I got to fix that. The way to fix that is to put a 2 here. Now I have 2 oxygens on the right, and I have 2 oxygens on the left. So the oxygen is completely balanced, but in the meantime, I added some more hydrogens. I put the 2 there, so now I have 2 times 2, 4 hydrogens on this side. So I got to make sure I have 4 hydrogens on that side. The way we do that is we put a 2 here. So now I have 2 times 2, 4 hydrogens on that side. I have 2 times 2, 4 hydrogens on that side, and the oxygens are still balanced. So I am now finished. I can just put a 1 in that one. Number 5. When you have more atoms like this, the tendency is to get nervous and get overwhelmed. But you just got to take it one element at a time. Let's look at Pb, that's lead. I have 1 lead atom over there, 1 lead atom over there. Okay, so that's balanced. What else is an easy one? Chlorine. I have 1 chlorine right there. I have 2 chlorines right there. So the way I can fix that is by putting a 2 here. So now I have 2 chlorines on both sides. Let's look at the oxygens. I have 2 oxygens on this side. The subscript applies to everything that's inside the parentheses. So that parentheses with the 2 outside means that you have 2 O's and 2 H's right there. Over here I only have 1 O. So I can fix that by putting a 2 right here. Now I have 2 oxygens on each side. Let's look at the hydrogens. On this side I have 2 hydrogens right there. I have 2 hydrogens right there. On this side I have 4 hydrogens right here because you have 2 times 2 is 4. So it looks to me like we are all balanced with this one. So I'm just going to put a 1 in the other spaces and we're finished. I'm going to skip ahead to number 10 here. Let's look for something that is not even. Okay, I got 3 chlorines right here and I have 1 chlorine right here. So I can fix that by putting a 3 in space. Now I have 3 chlorines on each side. I have 1 sodium on this side. I now have 3 sodiums on this side because I wrote that 3. So that's not balanced. So the way to balance that would be to put a 3 here. Now I have 3 sodiums on each side. Let's take a look at the O's and the H's. I got 3 O's on that side. I got 3 O's on this side because you got your subscript down there. Let's take a look at the H's. I got 3 H's right there. We got 3 H's down here too because of the subscript. So it looks to me like everything here is balanced out. I'm going to put 1's in the empty spaces. We have 1 phosphorus right here. We have 2 phosphoruses right here. That's an easy fix. I just need to put a 2 here. Now I have 2 phosphoruses on each side. I have 2 O's right here. I have 5 O's right here. Well, that's not good. So what can I do to make them both the same? Well, there's no number that I could write here that would make it 5. I want to have the same amount on each side. I want to have 5 and 5. But that's impossible. You can't do that because there is no number that you could put here. Nothing times 2 equals 5. So when that happens, just like before, you have to pick the lowest common denominator. The lowest common denominator between 2 and 5, the number that they both multiply into, is 10. So you have to make both sides have 10 O's. So that would be putting a 5 there and putting a 2 there. Because 2 times 5 is equal to 10. 2 times 5 is equal to 10. So now I have 10 O's on each side. So let me go back and make sure everything looks good. Oops, I didn't mean to erase that. We got a 5 there. We had a 10. Oops, yeah, we had a 5 there. We had a 2 there. So always go back and check your work. Let's make sure everything is balanced. I added the 2 here, so now I have 4 phosphoruses on this side. So I got to go back over here. I wrote a 2 there earlier, so I'm going to erase that. And now I'm going to go back and put a 4. So now I have 4 P's on each side. I have 10 O's on each side, so I'm finished. Let's take a look at the sodiums. I have 1 and I have 1. Okay, that's good. Let's look at the O's. I have 1 and I have 1. Okay, that's good. Let's look at the H's. I have 2 there. I have 1 there and 2 there, so that's a total of 3. I have 3 on this side. I have 2 on this side. So we need to think about a low number, the lowest possible number that we can have of hydrogens on each side. Well, these hydrogens are separated. I got 1 over there and I got 2 over there. So we can make it so that there's 4 on this side. That would be possible. I could do that by putting a 2 right here. If I put a 2 right here, then I have 4 hydrogens on this side. And I could also have 4 hydrogens on the left side by putting a 2 right there. I'm going to erase some of this stuff just to clean it up, and I'm going to rewrite the numbers that I just said, a 2 there and a 2 there. So again, what I'm doing here is I want to have the same number of hydrogens on each side. I originally had 2 on this side, I originally had 3 on this side, and what I realized I could do is I could have 4 on each side by putting the 2 right there, which gives me 4, and by putting the 2 right there, which gives me 4 total H's on that side too. So now I have 4 hydrogens on the left, I have 4 hydrogens on the right. So I'm finished with hydrogen. Let's go back and look at some of the other ones. I put a 2 in front of the Na, so now I have 2 Nas right there. So I got to go back over here and put a 2 there, so now I have 2 Nas. Everything else looks good, so I'm just going to put a 1 over here. So we're just going through piece by piece, making sure everything is exactly the same on each side. It's sort of like a puzzle. Let's take a look at the fluorine. I have 2 F's right here. I have 1 F right here. That's an easy fix. I can put a 2 right there. Now I have 2 F's on each side. Now I have 2 Nas right here, and I only have 1 Na over here. So I can put a 2 here. Now I have 2 Nas on each side. Let's look at the Brs. I have 2 Brs on this side. I have 2 Brs on that side, so that's good. Looks like I have 1 calcium on this side and 1 calcium on this side. Okay, that's good. So it looks to me like everything else is balanced. So we can just put a 1 there and a 1 there. When you see something like this with a lot of elements, you just want to look for an element that's by itself first. So I don't want to start with the H's. Because, I don't want to start with the O's. The O's would be a bad thing to start with because you got some over here, and you got some over here, and you got some over here, and you got some over here. And it's just a lot to keep track of. It's too much to think about. You want to think about something where there's only one of it on each side. Like, for example, the Na. That's an easy one to start with. Look, there's 2 Nas right here, and there's 1 Na right there. So that's an easy fix. So I'm just going to put a 2 here. Now I have 2 Nas on the left side and 2 Nas on the right side. Let's pick another easy one. How about the N? There are 2 N's right here on that side, and there is 1 N on that side. So that's an easy fix. I can just put a 2 right there. Now I have 2 N's on each side. Let's count some of the other stuff. H's. I have 2 H's over here. I have 2 H's over here. Okay, so that's good. Let's look at the O's. I got 4 O's right there. I got 4 O's right there, because remember it's 2 times 2. I got 4 O's right here, because remember it's 2 times 2. And I got 4 O's right there. Okay, so that's balanced. 8 O's on each side. So it looks to me like everything is all good. So I'm just going to put 1s in the blanks here. Okay, I hope that this was helpful.